All right. All right. Lesson 5. Two-way frequency tables. The probability that someone has black hair and brown eyes is 0.22. The probability that someone has a black hair is 0.35. What is the probability that someone has brown eyes given that they have black hair? That's right. 0.22 on top, 0.35 on the bottom, 63%. Today we're going to talk about two-way frequency tables. We're going to make one, and then we're going to have a couple questions about it. So, data can be presented in many different ways. In previous lessons, you worked with data presented as a sample space, a subset of a sample space, fractions, percents, or their decimal equivalents. Frequency is a number that tells how many times something happened. Again, this will be a key vocabulary word you'll see in the future, so you may want to write this down. A two-way frequency table is a table that shows two categories for characteristics, one in rows and the other in columns. Each cell value is a frequency that shows how many times those characteristics, appear together. This is kind of dabbling back a little bit in coordinate algebra, and even back in middle school. When you're presented with a great deal of data, two-way frequency tables can provide a convenient way to compare the frequency of data items and see the relationship among them. Here's an example. For example, for some reason, red hair is through the roof. I can't see why, because red hair is a rare trait. Must have been next door to some red hair convention. I don't know. Boop. We previously learned that you can find the conditional probability of B given A using this formula. Took notes on that last time. This also works if you use the number of outcomes in A and B over a number of outcomes in A. This is what I like to think about when we're doing conditional probability. So if you want to take time to write that down too. Boop. Reminder, events A and B are independent if probability of B given A equals B. And remember, independent. So the events A, if it does not affect events B, they're independent. We talked about that when flipping a coin and rolling a dice. Flipping a coin is not going to affect the dice. Boop. Also, probability or conditional probability statement. I think we wrote this one. Don't forget and is the intersection idea. So here's another example. We're collecting data. Student council wants to host a school-wide activity. Council members survey 40 students, asking them to choose either a field trip, a dance, or a talent show. The table on the next two screens show the survey results. Boom. Here's the first 20. You know, the time or counting the responses, the grade they're in, what they chose. And here's the last half. So there are 40 students. Two characteristics associated with each student is the grade level and choice of activity. Your table will show grade level on one side and activity choices on the other side. So if you're following along, you can construct a table yourself. We're going to put tick marks and keep track of who chose what. And when we get a grand total, I think you remember this counts as 5, 3, so this should be 8. And we're going to replace all these with actual numbers so we can quickly see the trends. Boop. Here we go. Here's a completed two-way frequency table. Talent show, we have 4 10th grade who picked talent show, 8 who picked field trip, and 2 that wanted to dance. So notice, I think we have a trend here. Seniors didn't too much like field trips, but the sophomores did. And seniors rather dance a little more than the sophomores do. I feel like there's a trend here. Blah, 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 blah. So, if we put the totals at the end, notice they should add up to 40. That's how many people were surveyed. Now let's talk about the conditional statement. Let's calculate the probability of 10th grade given that they picked field trip. Now I want you to see the difference between field trip given that they're 10th grade. Should they be the same? Should they be different? Well, I'm just going to go ahead and show you this so you can see where the numbers come from. So, 10th grade field trip. Remember, the idea is going to be that they are both, remember the conditional formula, over that first event. Remember, the first event, there was B, A, so really it's going to be over field trip. When we say both, remember that's both 10th grade, okay, and field trip. Is a conditional statement. In fact, I'll even tell you another way I like to look at it. This is the fraction bar. Field trip on the bottom, 10th and field trip on top. So, either way you want to look at it, you be the judge. I know that we got to look at the 10th grade field trip. We have 8. And as you can see from the answer, that's where they got the 8 from. The 12 came from everyone who picked field trip. Notice the total was 12. So that's where we get 8 over 12. It's field trip and 10th grade. They intersect right here at the 8. That's going to be the both idea in our formula over total field trip. Okay. I'm going to use, I don't know, blue for the snakes idea. So if we did field trip 10th, it's going to be the same thing. 10th and field trip over this time the total of 10th graders. So same intersection here, 8, but this time the total is 14 out of 10th grade, given that they're 10th grade. So we get 8 over 14. And again, reduces to 4/7, just like the other one was 2/3. That's where that conditional statement idea comes. In fact, you see more of it in the two-way frequency table problems. So calculate the 10th grade, picking a 10th grader given that they pick field trip, and 10th graders. Are 10 and field trip dependent or independent? So give that a quick little thought. Think about the formula. Think about what we said about them being the same or different. What would that mean? All right. Again, I assumed you paused it, so now you hit play again. Boop. So if we look at our numbers here, 2 over 3, 7 out of 20, our 10th and field trip dependent or independent? So if 10th and field trip were independent, then 10th grader given that they picked field trip equals the 10th grade. But it does not, so they are dependent. Okay? See? Two different, which makes them dependent. Remember, independent, they would have to equal the same thing. This is just writing sentences, describe each of the following and what they mean and how they are different. I'm not going to go over this, but it kind of helps clarifies why we're picking what we're picking. If you want to, you can write that down. Totally up to you. If you get it, move on. Again, let's calculate talent show given that they're 12th grade and determine whether TS and 12 are independent. You probably already know the answer to this. But real quick, let's recap that. What would this equal? Again, talent show and 12. Talent show and 12 would be 2. Given that they're in 12th grade, should be over 12. 2 over 12 reduces 1/6. Boop. Indeed, it is 1/6, but as you notice, those of them that pick talent show out of the total number of surveys. So talent show added up to 11 out of the 40. As always, they are different, so that means they are dependent. Okay, this probability really depends on what grade you're picking from. And that's it. It's two-way frequency tables. Here's the worksheet. I got the answers posted. So give it a whirl. Good night.